All right, everyone. Thank you for joining us on Modern Database Performing Tune-in Methods. I want to let you know this is being recorded by Denny Cherry & Associates Consulting. The recording will be available as soon as I get it downloaded and processed and re-uploaded. So if you do not consent to being recorded, go ahead and disconnect now, and you can watch the recording later. All right, now that all the legal stuff is out of the way, I'm Denny Cherry. I'm the CEO and Principal Consultant for Denny Cherry & Associates Consulting. With me is Tom Rock. He's one of the head geeks over at SolarWinds. Tom, say hello.
Hello.
So welcome everyone for coming. Thank you for joining us today. Tom and I are going to be talking about modern database performing methods and what you can do in SQL Server, the things you can do yourself, the things you should be using a vendor tool for, and the things that you might actually want to outsource to a consultant and have them look at for you. So a couple of housekeeping things to talk about real fast. If you do have questions, please put them in the Q&A panel that's in Teams Live Events. Do keep in mind that there is going to be a slight delay between when we talk and when you hear it. So if you do ask a question in the panel, give us a couple of minutes before we can actually answer it, or at least before you actually can hear us answer it, just because of the delays in live events. We'll try and answer any questions that come up during the session. At the end of the session, we'll have a Q&A slide, and if there's any questions we haven't answered, we'll go ahead and talk about them then and get those answered for you. If there's anything we can't answer or that takes too much time, we'll go ahead and just put it in a blog post or something and get that information out as well. If you think of something to ask, please ask it. Somebody else probably has the exact same question as you or something very, very similar. So your question might not just help you, but it'll help somebody else, or maybe spur somebody else to come up with a question that they would like answered as well. So the things Tom and I want to talk about today is performance tuning that you can do yourself, performance tuning using vendor tools, and then using a consultant to do that performance tuning. When is that good point to actually call somebody to have them do performance tuning for you? We're going to do some Q&A at the end and make sure that everything's answered. So doing it yourself, I know this is a topic that Tom holds near and dear, is polling versus tracing. Tom, do you want to go off on this one first?
Go off. That's a great way of putting it. Yes, I want to go off on this.
I figured you did.
Now, here's the thing. When you start in your career as a DBA, and Denny, I think you can remember back, it was just a few short years ago for a youngster like yourself.
Just a couple, yeah.
But there's a tendency to have this idea that you need to use a lot of tracing. So back in the day for us, right, it was Profiler, and then it became extended events, but it's the idea of capturing all the events as they're happening in order to do or use that for your diagnostics. And I know I certainly believe that was the way that you had to do some sort of monitoring and tuning, but you also realize that you enjoy things like sleep. And you can't be tracing everything and capturing all the events and metrics all the time. And you can't certainly just turn it on when you need it at 2 a.m., right? So you get this idea that, I know what I can do. I can just capture some relevant metrics at different points in time, and that's called polling. And for a lot of use cases, I'll say 98% of the time, polling gets you all the data you need in order to be effective with performance tuning and monitoring. So those are really the two camps you have, right? And so that's kind of why I put that on the slide. I think you've had similar experiences.
Yeah, I have. And sleep is definitely something that I remember not getting an awful lot of back when I started doing this, because you can only look at things so much, and you need to figure out how to actually make that switch over to looking at snapshots of the system rather than trying to review what the system is doing constantly. On top of that, one person can't look at the workload of an entire server. You've got lots of people using a system. So if suddenly you've got 100 people running queries against the system, you're only one person. You can't read all of that and scroll through all of that to figure out kind of what's going on. So back in the day, back in the olden days of 20, God forbid, 20 years ago now, we had DBCC SQL Perf, and that would give you back some useful information. And it's basically almost all we had back in the day was these sorts of random commands to get back information like DBCC SQL Perf. There was some other stuff you could do, but you were dealing with a very minor amount of information, especially when you compare it to all the good stuff that you can get today. Thankfully, Microsoft was able to figure out, hey, we actually do need to have more information than just these really random pieces. And that introduced what was a massive, massive improvement of the dynamic management objects, so the DMFs, the dynamic management views, and the dynamic management functions, the DMFs and the DMVs. So, Tom, I don't know if you remember when these came out, but I was thrilled with all the information that we could suddenly see, because we went from this tiny little amount of information that we could get from SQL Server as to what it was actually doing, and we suddenly got this huge flood of information. In some cases, more information than people needed, but in most cases, things that people could actually use and data people could actually use if you looked at most of these.
Yeah, so I would say, and the reason we have the SQL 2000, I know it goes back 20 years, but that was all you really had, right? And that was really, it was kind of a snapshot. So you could use that in order to get information at periods in time, and you could store it somewhere. It was also, I liken it a little bit. I say it was a consultant's dirty little secret, right? They could show up, they could run a few of these commands, they could get some information. Oh, look like you're mostly waiting for disk or for CPU or something, and they'd have an idea of how to attack, say, tuning that particular instance. But yeah, then they rolled that, and so that led to, of course, the white paper by Tom Davidson for weights and queues, which gave us the DMOs in 2005. And yes, I do remember being there and thinking to myself, I have a gold mine of information now. I get just about everything I need. And what do I want to do with it next? Where am I going to store it? How am I going to use it? And so on.
Yeah, thinking back like to the olden days, the golden age of SQL Server, it's amazing just how much we could do with so little information back in those SQL 2000 days. And SQL 2000, it wasn't just prevalent in 2000; it was prevalent up until 2010, 2012. I mean, it was a system that was running in, I wouldn't say majority, but a lot of systems up until probably 5-8 years ago. This was kind of, I think, the last time I really saw SQL 2000 floating around.
So we commented how it's 20 years ago for 2000, but 2005, that's 15 years ago, and I'm willing to bet people listening right now are going, I'm still using those DMVs. That's exactly what I'm doing today. So you're using technology that's 15 years old at this point. They've updated some of the data behind it, but again, the concept of these DMOs, it goes back a ways now.
Yeah, it does, and it goes back a long way, and thank God we had it, because we wouldn't have some of the other stuff like X events. Certainly, without some of these DMOs getting introduced back in the early beta and early alpha days of SQL 2005. And that leads on to our next thing we want to talk about is the whole X events thing being introduced in 2005. And I will admit, it was not great in 2005. I believe the phrase was "it sucked," but it's gotten significantly better over time, because it has had 15 years to mature in 5, 6, 7 major versions since 2005. And every single time they've improved upon it, and it's gotten better and better and better as it's been released.
Yeah, in 2005, it was event notifications, right? That came out. Was that it? I mean, X events was that, but you used event notifications, and it was kind of a hard thing. Most people probably wouldn't bother trying to set up the notifications for that. In 2008, it got a little bit easier, but still, yeah. this is the technology that we've been using for quite some time. This is, if you're going to do it yourself, this is the world that you're going to be living in. DMOs and X events.
Yeah, I mean, extended events are super powerful. They can show you pretty much every single thing that's going on in your system, and way more than you ever wanted to actually see, because they're extremely powerful, because they can show you not just what queries are running or we're running, but there's all sorts of administrative events that can be fired, all sorts of background processes that can go off. And so you can see exactly where things are hidden in the background. So extended events are the kinds of things that the SQL Server Engine team actually uses when they're looking at the engine and looking to see where performance bottlenecks are in the engine. Is they'll look at a lot of this X events information to figure out what's actually going on. So all they've done is simply expose that to us, the users, so that we can simply continue using that same information that they're using in the background.
Mm-hmm.
Now, one of the great things that was introduced in SQL Server was introduced in SQL 2016, and that was the query store. Now, I remember seeing this on an older version of SQL Server as a preview when they were still working on it. Tom, you were probably in the same sessions I was.
Mm-hmm.
And I mean, it was really cool back then, and this was long before the polished, finished product was able to come out in SQL 2016. And this is basically that black box for SQL Server that helps you look at everything that could possibly be going on inside the database engine and with the queries that are running. And it's capturing not just some runtime information, but it's also gathering the execution plans, so you can go back in time and go, all right, this query is now running fine. It was running like crap overnight. Why was it running horribly overnight? Let's go take a look at why it was running badly and figure out how to fix that. And we can actually pull up the execution plan that was happening at that old point in time. So we can actually see what was going on with that actual query.
Yeah, and I would say one of the drawbacks to the DMVs, of course, is that they're reset upon a server restart or if they get flushed. And depending on which one you're looking at, sometimes they get flushed from the system and you may not even know it. I forget which ones those are. But the point being, when you have to do that polling, that constant polling, and you have to store it yourself, and Query Store took that pain away, because Query Store gives you that persistent view between restarts now as it collects the information. It's basically having your own little monitoring tool for each database on your instance.
Yeah, that was one of the really big selling features of Query Store, the fact that it could and did persist that data across restart. So even if your database server failed over, so maybe you had performance problems and then something crashed, and then, or say a hard drive crash, and then your database failed over to another node in your cluster or in your availability group, the Query Store information would go with it and still be there and still be available for users as diagnostic data to see what's going on. And that was a huge, huge thing to just have it be there. As a consultant, this is one of the dirty little secrets we have, is we simply tell the Query Store to turn on in databases when we're trying to troubleshoot performance problems, and it's going to gather a huge amount of information that we want to see simply by flipping it on, and it's extremely low overhead. Query Store is typically about 1 to 2% of the CPU load on your server. And that's not the total CPU possibility. That's just of the load that you're running. So if you've got a server that's running 10% CPU load and you flip on Query Store, you can expect the server to go up by 0.2% CPU. So that's not a lot of CPU. So Tom, I think that you want to show us some Xevent stuff.
Yeah, let me make sure I've got my stuff here. Yeah, that's running. How do I request control, or do you just give it to me? Oh, wait, there it is.
Yes.
I share tray.
Yeah.
Share. And can you see my screen? Yes.
Yes.
Okay, good. So what we're looking at here is Azure Data Studio, and I have an instance of AdventureWorks running against a VM in the cloud. Don't copy down the IP address, please. Anyway, I know I should have blurred it out, right, somehow. So what we're going to do is I want to show what I have here is I've loaded the SQL Server Profiler extension. Now it says Profiler, but this is using extended events. And of course, I'm running on my iMac here. So I like to show off how I can use SQL Server tools and products on any platform these days. So that's why I've chosen Data Studio, and that's why I'm going against an Azure VM in this particular case. So what we have here, in order to get that started, all I need to do is Control-Alt-P, start a new profiler session. And again, it's extended events. Which ones do I want? Let's do T-SQL on-prem. Why not? And we'll get that started. So I've got a workload running, thanks to Bradley Ball. He put together a little workload generator, just running a handful of sessions against AdventureWorks, and you can see all the data that's coming in. And this is, like we said all those years ago, this is typically how you collect diagnostic information, maybe when you were starting out, or let's say somebody's telling you that there's a performance problem with SQL Server and you're not sure what it might be, so you fire off some standard X event trace just so you can start collecting the information you need. The first thing I would tell you is you're gonna have a problem with this method. Just doing it in this particular way. This is going to be overwhelming if you're new to SQL Server, and the problem is going to be, where do you go from here? What are you supposed to do next, right? How long does it run for? Do it a minute, an hour? It's kind of difficult to work at times with this tracing information, and I try to remind people that you should think of it more like a surgical tool. You should know when to turn it on, what you need to be looking for, and it should be precise. If you're using it in this manner to just gather everything, it's going to be difficult, because even if I come up here and I say, all right, let's stop, what view do I want? I don't know. Let me look at a tuning view of the data, I guess. And what am I going to look for next? I guess I can filter by duration. Maybe I'll just filter on specific database, and I'll just go down. What happened? It didn't come back? I don't know what just happened. Oh, I stopped it. Let's try the tuning view now. There we go. So here, and then of course I can filter, and I could say, all right, but the point there is that's a lot of manual work on my part. I'm basically, you know, SQL Columbo at that point, trying to figure out where this data is, where the real problem is. There's nothing in this raw data that's coming back. There's nothing here to highlight and say, this is the problem, this is what you should be looking at, and more importantly, this is what I'm supposed to do next, right? None of that is really here. I have a wonderful data set that has some value, but it's just a little cumbersome to work with, especially, as I said, if you are new and you think, hey, I've got to use extended events in order to get the job done, that may not be the right choice. All right, I'm going to stop. How do I give you control back? Oh, there it is.
I will just take it.
Yeah, you take it.
So one of the things I wanted to do is show off a little bit of the query store. We'll get my,
and actually, Denny, if you're going to show Query Store, we actually have a couple of questions.
Yep, I was saving those for the middle of while I was doing this.
Yep, you got it.
So
Making
let
sure.
me show off Query Store real fast. Then I want to address those two questions because those are both excellent questions that I've got sitting in the queue here. So the Query Store, it's a background process. It just goes through and collects all sorts of information on your system, and it bubbles that information into some basic reports that are available through Management Studio. So unlike Tom, I am on Windows, I know, for me. So I was running the same workload. This is just Bradley Ball's workload generator here. And it's going to show you a bunch of information about your system in these nice, pretty graphs. And then it's also persisting all this data into actual tables. So you can go query this information if you need to. So here we've got just one of the generic reports. So this is top resource consumers for AdventureWorks, which is what this workload generator is based on. I can see here the store procedure that was being run is p cell get sales queue by prod, order unit line. Ignore the names of the stored procs. They're horrible. They're by Microsoft. And you can see what the execution plan looks like. Now, I only ran this a few times, so I don't have a bunch of different execution plans. But if I did, you would see these here under plan ID. You'd see different colored dots, one for each different kind of plan. If you simply click that dot, it'll then let you see that specific execution plan, so you can see the differences between them. And one of the really cool things you can do with this is you can then force the plan. So if you see a plan that's working better than another plan, you can actually select that plan and click Force Plan here. And then when you click Yes, that will always use that specific execution plan every single time that query executes. So this is really great to figure out what the highest consumers on your system are, and you can go then attack those first. So the next query here is queries with force plans. I don't have any, so there's nothing in that graph, so I can just close that. So next one is queries with performance variations. So this is going to be things that have changed over time. Obviously, this is going to be a little weird looking on my graphs because I don't have different plans for every execution of my queries. But as you can see here, you can just flip through your queries and you can get all the execution plans for these and see which ones you want to attack from this particular way of looking at things. You can also look at the weight stats on the system and see what's driving those weight stats. So here, this is a SQLDB database. So this obviously works in SQLDB as well. If I click on the weight type, I can see what query was actually driving that weight type. So I can get a lot of really powerful information here from the system. The last option is tracked queries, but I don't have any tracked queries because it's just a demo. So first question that I had in the question queue here is there any reason not to enable the query store? So I'm going to give the standard consultant answer of it depends. If you've got a system with just a couple of databases, even if it's got a decent amount of CPU load on it, 40, 50, 60%, it's probably still worth enabling. If you've got a system that's got a ton of small databases, you don't probably want to enable it on all of them, especially if those databases are all the same. You want to pick a few databases, a few of probably your biggest hitters, and turn on the query store on those specific databases so that you can gather information on a few databases, because that database, the information will be representative of all the information across the entire system. And then you can use that information to troubleshoot any performance problems and look for any performance variations. So the other question here is, would you ever want to flush the query store? Probably not, just because the query store is going to have a lot of old information that's actually really good. Now, if the old information is all useless to you, then it might make sense to flush it, but you probably just want to let that data expire out and age out anyway. So turning on the query store is a fairly simple process. You simply go to the properties of the database, and give me a sec here because this is Azure, so it's got to come up here. And go to the query store tab. You'll set the operational mode from read only, or off rather, to read write. You set the data flush interval, and so this is all going to be defaulted to what you see on the screen here. So you want to set the data flush interval, so it's how often data flushes down to the query store. The collection interval, how many plans you want per query, the max size of the query store. Now this is a setting that can be interesting. On low load systems, 100 megs is probably fine. On really high load systems or systems with absolutely huge query plans, so say a data warehouse, you might need to increase this from 100 megs to a gig, maybe even a few gigs. I know we've set it to a gig on most of our client systems that we deal with, just because we want to gather a lot of information, and these are relatively high loaded systems. I've had some where I've had to push this up to 10 or 15 gigs, just because they process through a whole lot of information and they can't keep the data for 30 days within 100, with the 1 or 2 gig query store. So we've had to push this up so that we can keep that data for a long enough period of time. Now, if your query store fills up, SQL Server is not going to throw error messages to your users or anything like that. It's simply going to flip this from read-write to this read-only option. So it's basically going to go into a read-only mode. So you can still see the data that's in there. It's just not going to be able to keep any additional data because there's no more space for it to fill up. So as you can see here, I've got these pretty graphs. I can see exactly how much space I've got left in my query store. And obviously you can query this data from the system. So question here, will query store bloat the size of your OLTP backups? So these are tables in the system. So because these tables are in the system, these are going to be included in your backups. So there's no really way to not have these be included because these are just objects in the database. So they will make your backups slightly bigger, but again, you're controlling how big the query store is. So it's not going to take over your backups of your system or anything. So if you've got a 20 gig database today and you sell 1 gig query store, you've got the potential for 21 gigs of data being backed up, but you'll want to be using back compression anyway. So that will help with that sort of thing. So as to the question of purging, when should you purge your query store, or should you purge your query store? There's this button right here, purge query store data, that will then take everything out of the query store that's stored in it if you were to click that button. Again, I wouldn't typically recommend doing that, but there are times when people do find it useful to actually dump all that data out for you. So the next thing we want to talk about was when you should switch over from trying to do it all yourself to when should you look at having an actual monitoring system in place, and when does it make sense to take that next step? Because that's something some shops have a lot of questions of. And this first thing is I would hope relatively obvious, but as your number of servers in your environment grow, you're just not going to have time to monitor all this stuff yourself. So that's going to be a really great metric to go, okay, now it's really time to start looking at this as an enterprise view, as kind of a holistic view, and seeing what is going on through the whole enterprise. Another bullet point here is if we spend more time writing code than actually administrating our databases. So the job of a DBA isn't to be writing T-SQL full time. So if you have to end up writing T-SQL to actually monitor your systems, and you're not actually spending the time actually doing the administration of the systems, this is a great time to look at one of these third-party tools, because then you can kind of get away from having to write these sorts of performance queries and figuring some of this stuff out, and actually going towards an actual third-party tool. So there's a query store question here. Is there a rule of thumb for sizing of the query store storage size? Not really. This is why we tell most of our customers, go to a gig and we'll see how long that lasts. The busier your system is, the larger your query store is going to need to be. The good news is making the query store larger is not an event that's going to require downtime. So you can make it larger on the fly, and then you can turn it back on, and then the query store will start working again. So now that SQL Server is available for multiple OSs, being able to do monitoring on those multiple OSs is going to be a big thing. Like Tom showed, he's running Azure Data Studio on his Mac, which is a native SQL Server management tool running on a non-Windows platform. So being able to support multiple platforms and having databases now running on multiple platforms is a really big deal, and being able to manage those and monitor those for the specific things on those different platforms is going to be a really big deal. So I don't know if you noticed this, but when I had Management Studio up, now I'm running on Windows, obviously, because Management Studio, But this top box here, this is localhost, but this is not a Windows icon. This is a Linux icon. That's because I'm running Kubernetes on my desktop, and I'm running Linux in a container on my Windows machine here. So it's actually a Linux container. So because of that, it shows up as SQL Server on Linux in Management Studio. So if I were to need to monitor this as well as my Azure Azure DB, plus some Windows servers I have, plus maybe some Linux servers that I've got that are running native Linux, that are running SQL Server on Linux. Now suddenly I've got a huge number of platforms that all are going to have their own individual little thing that needs to be monitored and measured. And those are things that I'm going to need to keep track of within my environment and within my monitoring tool. And I don't necessarily want to have to know the differences of the platforms within, with how all these weight types are going to be addressed in the operating system. I just want to know, hey, SQL Server is seeing slow X. I need to address that, and not without knowing the actual nuts and bolts of what's necessarily running underneath. The nice thing about a monitoring tool is it can do a lot of that for you. Excuse me. There have also been a lot of architectural advances over the years, and those are things that we want to address and we need to be able to maintain, especially both internally within our systems and externally as well. There's just architectural advances that are happening in the enterprise in general. And if we use a third-party monitoring tool to monitor these sorts of applications, and we don't have to necessarily know about a lot of these changes that are happening in the IT world, we can let them happen and we can embrace them, and we can let the monitoring tool take care of this, because the folks at the monitoring companies are going to be the ones that are going to be taking care of a lot of this. Tom, is there anything you want to add to this while I cough some more?
Yeah, I'll give your voice a rest for a minute. So just a few things. The time coding, that hits home for me, because that was the point I reached where my day-to-day activities were essentially, I was the product manager for the in-house monitoring system. And I was in charge of a team of DBAs, but I sort of realized I was spending all my time basically just building this product, and I wasn't really doing any of the database administration duties, right, that needed to get done as well. I was just handing all that off to others. And we grew from a certain number of servers to a larger number, and I just said, no, it's time to bring in the tool. But the other reasons, these also ring multiple platforms. When Aaron in accounting all of a sudden decides to buy a new product, but this one's going to run, Sybase, or the artist formerly known as Sybase, or it's going to run Oracle, or these days Postgres maybe. All of a sudden, all the scripts you have, all the stuff that you've built, because maybe you thought you were just going to be a SQL Server shop. Guess what? You're not. Or maybe they decide to use Postgres, but it's Azure Postgres, right? So you've got multiple platforms, and then on top of that, the architectural advances are things like everything we've talked about for monitoring so far, right? Profiler, tracing, DMVs, X events, query store. Every one of those is built upon the assumption that your workload is on a single node. It's sitting on that server and nowhere else, and it's focused on just the engine. But these days, with availability groups, or with the ability to scale out and use, say, Azure Postgres as your backend, not a lot of tools are built with the idea that your system is distributed globally. And that is going to be an issue for you as well if you aren't changing the way you approach performance tuning and monitoring for these modern workloads.
Yeah, I think that last little bit that you just said, I think is a really excellent point. The changing world for modern workloads. Like, if people aren't keeping up with how things are changing, then they're going to end up getting left behind by a lot of these, because you are going to end up with people in the company buying random products that they need to actually work with, and those are just going to get tossed over the fence to IT and go, here, set this up. Congratulations, we've already bought it. We're not interested in your opinion of the product. or opinion of the database that's going to be running underneath this. You just need to support this and figure out how to make this work. And by the way, the vendor is going to be here tomorrow.
Mhm.
So good luck. Like, I've had this happen in the past when I've worked at shops. Like, this was a thing that would happen. Is somebody from business would go, hey, we've got a meeting at 3 o'clock tomorrow afternoon to talk about how the vendor is going to be deploying the software tomorrow afternoon.
Yep.
So you need to figure out how to make this happen. And like at some point, sometimes we literally had to buy hardware. So it became a real problem real fast. So we had a question in the queue here. Will Query Store provide better information in a deadlock than X events? I don't believe so. I believe you're going to want to look at the X event to actually look at the actual deadlock information. I don't think Query Store is going to have anything all that helpful. Can you think of anything that would be in there, Tom?
No, I was going to say, I thought it was using X events in order to grab information. So it's not going to provide any better info than an X event, as far as I know. There's nothing else. There's nothing special in there.
Yeah, and specifically on the deadlock, I don't think Query Store is going to be all that helpful at all, because it's only grabbing running queries that have completed.
That's true.
With the deadlock, the query dies before it starts. So I don't think it's going to be in there. I think you're going to need to get an X event session spun up to actually capture the deadlock information.
Yeah.
So some modern problems that people have is distributed systems. Like these are a realistic thing in the database world now, where we take what was a single system and we distribute it out across multiple nodes through some way, either a relational system or a non-relational system. Sorry, I think I keep interrupting you, Tom.
No. Oh no, we're good.
Okay, cool. So these are things that are distributed, and we need to figure out how to look at and how to monitor. And third-party monitoring tools are a great way to actually monitor these systems, because it doesn't matter how big the system gets, how wide the system gets, we can still look at them as one enterprise-level view instead of having to monitor all these individual systems, as independent components. There's 4 things you always want to monitor on servers: latency, traffic, errors, and saturation. So latency, that's going to be how long things are taking to run. Traffic, how many things are running on the system. Errors that come up, errors are obvious, things that go wrong. And saturation, what level we're hitting all the servers and how full we're actually pushing all those servers, how close we're getting on those boxes to 100%. Monitoring those in real time by yourself is really, really hard. Moving towards a third-party tool makes monitoring those much, much easier, because you don't have to look at them in real time. You can look back historically at them and go, hey, what was going on in my system yesterday? And most importantly, how does what was happening yesterday correspond to what happened last week, last month, last year? And you can look at all this history of your systems and see what's actually going on over time. Now, one of the big things that Tom and I both like to drive home is you don't want to tune an individual query. An individual query is going to be part of an ecosystem of your system, and it's part of that overall workload. So while you need to fix queries, you need to look at what those queries are in the overarching scheme of things. If you've got a query that's taking a couple of milliseconds to run, but that query is being run 8 billion times a second, we probably need to look at that. But we won't know that until we look at the entire system and see what's really going on the box. Now, Tom, I believe that you had another demo for us.
Yeah, I do. Let's see here. Yes, I'm sure I want to share. And can you see my screen? Yes, I'm presenting. All right.
I see it.
Good. So I was just going to spend a few minutes talking about some of the SolarWinds tools, specifically how they address some of the problems or some of the, say, modernization of workloads. So that last slide, Denny, where you're talking about tuning the workloads, not the queries. When people remember on the call, I went back and I was showing you the X event trace, how easy it is to get started, but it's kind of a little cumbersome to work with because you got to do some analysis on your own. You got to know what to look for. Imagine if you had all these traces across a whole bunch of different servers. But on top of that, again, that trace is focused on just that one engine and not on, say, if the workload itself is distributed across multiple nodes. And so you've got to kind of have the ability to figure out, what's the right solution? Because a lot of tools were built for an earlier era. And we really need to think about, hey, if this system is architected in this particular way, we're going to need to monitor and look at it slightly different than what we've been doing in the past. And what I have here is I have DPA, and DPA has been around for, actually it goes back maybe 15 years now, 10 years for myself since I joined the company. And we, of course, we monitor more than one platform. You can see the list that I've grouped here. We just added Postgres. So a lot of good information. There's going to be just a couple things I want to point out real quick here. One, from this dashboard view, I get an idea of, it's the executive dashboard, right? The reds, the greens, the yellows. I'm going to drill into this particular server, and this red, and it says critical tuning advisor issue has been detected. So what we do, now imagine if you were aggregating all this data for yourself using DMVs, you're going into DM exec requests and sessions, you're gathering information on specific queries. And like Denny and I said, you want to tune the workload, not a specific query. And this is going to be a good example of why. So in that X event session I was capturing a workload, and that workload is made of a lot of specific individual queries. A lot of times I see performance tuning device, and it'll say, show me, or how do I get a list of the top 10 queries that are consuming CPU? And these days I think to myself, that was maybe a way to do performance tuning 15 years ago, but it really doesn't apply anymore. Because I could spend a whole lot of time trying to tune that one query, and it's not gonna make the system, the workload, necessarily better. And that's gonna be true if I'm only focused on that one query, then I can't see the forest through the trees, right? So what we have here is what we've done is we take the information that's being collected. So our quick poll does a join between exec requests and exec sessions, I think, and pulls back information from DMVs, and we store it, and then we aggregate it, and then we give you some analysis on that. And what you're looking at here is what we call our table tuning advisor. So the idea is very simple. A lot of times you'll go to tune the query, you'll look and you say, hey, you know what? I know what the answer is. I just need to adjust this index. I'll add a column, or I'll include a column, or maybe I need to drop this particular column from an index because it's overlapping. There's lots of ways for you to tune an index. However, a lot of times you're doing that, you may not have any idea how many other queries are touching that index or that table. And that's one of the things we highlight right here for you. If you look at this particular line item table, I can see right now 72 queries are hitting this, and they may benefit from tuning, and we have 4 index recommendations. That's not information you're getting out of DMVs directly. This is the analysis that has to be done on the data that you be collecting. One click, I can come in here, I can view the plan, I can see the index recommendations, I can get the DDL from it, but more importantly, we're going to give you some insights, like what we call best practices. This isn't information you're going to get out of a DMV. There's no DMV inside of SQL Server that says, hey, you didn't index this foreign key. You've got to know the benefits of indexing a foreign key, and then you've got to go run it and then do the analysis yourself. But we can roll all that up for you right here. And we can tell you, look at this. You've got a foreign key not indexed, you've got overlapping indexes, you've got wide indexes, and this table doesn't even have a primary key, right? And it does have at least one index, yay you, but there's so much more improvement that can be done here. And we can highlight that for you in a very, very quick and easy manner. A couple more things, and we're going to bounce over to something else. Another thing I want to show is I'll just come to the home page for that particular instance. So you'll get by default a 30-day rolling window inside DPA. Everything you see here is an aggregate. If I hover over something, you're going to get the total number of executions for across all sessions for the entire day. That's why in this day, you can see the total wait time for the day says 60 hours. How can you have more than 24 hours of wait in a day? Because it's an aggregate, all sessions, all executions. So normally you would look at this and say, all right, well, the day with 55 or 60 hours of wait, that's the biggest bar. This is where I should focus my energies. But no, down here we have this thing called anomaly detection. So this is actual math being done here. This isn't just rules-based recommendation. This isn't just a threshold and a baseline and saying you went over it. This is us building a prediction and saying on October 3rd, we predicted a certain amount of weight and you went over that. And you went so far over it that it's now critical. So now that bar up top may not be as high as the others, but there's an anomaly on this day. This is the signal through the noise. You got 100, 200, 300 servers and you're wondering which one to look at. Anomaly detection is how that gets done. And then last thing I'll say is locking and blocking. I saw there's a question about deadlocks as well. Well, we're going to be able to highlight that information for you right here as well. A lot of performance issues or issues in general with relational database engines come down to concurrency, locking, and blocking, and just understanding how they are all related. I actually have a webinar in 2 weeks on that topic for SQL tips. So small plug there for myself, Denny. Thank you. And we highlight the blocking, but we also, I don't know if there'll be any here. We also call it the deadlocks. If they're here, you would get the deadlock graph information. You'd be able to find out those details. We are using Xevents in order to capture the deadlock information. All right, so that's DPA. That is kind of the standard that we have at SolarWinds for when it comes to the expert advice you need for what's happening inside a database engine. We also have this database performance monitor. This is formerly known as VividCortex. We purchased that company last December. This is sold as a service, right? So we host everything for you. This is subscription based. And what you're seeing here is the modern monitoring platform and the concept of, as you can see right over here, latency, throughput, concurrency, error rate, right? So now, if you've got that distributed system, you've got those 4 golden metrics sitting right here. Now you can attack and say, all right, tell me what was happening on the server at this particular day. If I come over here to say Explorer, I can get an idea of the queries that we're running and also correlate to what's happening on the server itself. Give me a more accurate representation of the workload for those particular nodes. Inside of DPM, I can also, I would know the cluster of nodes that were involved in the particular workload, and I'd be able to go through and say, all right, I can see, like, is the load actually balanced or not? And those are the questions you need to answer first. And that's when we say you want to tune that workload and not a specific query. Because if you can imagine spending 8 hours of your day trying to fix one query that happened to hit one node, and you're like, yay, I got it done. But you know what? You made no improvement to the actual system itself. And you want, your time has value. So you want to use a tool that's collecting the right metrics in the correct way and highlighting it and giving you that expert analysis and saying, you know what? This is the problem you're having, and these are the possible actions you should take next. Denny, I'm going to give control back to you. We got about 10 minutes left. Or you take control.
Sorry, I was going to say something witty, but I couldn't because my mic was not turned on and I couldn't unmute while I was selecting the monitors to grab.
Yeah.
So if you'd like to grab a copy of those tools that Tom was just showing off, you can just go to dcc.com and scroll down. There's a SolarWinds button on the right. You can click that, and we'll send you over to get some information on an eval version, so you can take a look at those products in your own shop. So we've talked about tuning stuff yourself and when it makes sense to tune stuff yourself. We've talked about using a third-party tool. So when does it make sense to bring in a third-party, i.e. a consultant like us? When does it make sense to actually bring them in to actually look at stuff within your shop? So the first reason that a lot of our customers actually come to us is because there's just stuff they need to deal with, and they don't have the time to deal with it because they're dealing with other fires. So this is a great time that people will bring us in and go, hey, these are the things we want to get done, but we just don't have the time. So maybe they want to do performance tuning. They know there's performance tuning that needs to happen on their system, but they just don't have the time to do that performance tuning themselves. So they'll actually bring us in and go, hey, we need a consultant to actually look at this and figure out how to make this faster, because we need to be able to run these queries more often, and we need to bring the CPU load consumption on the server down. Another reason people will bring us in is because they've already done all the tuning they can do on the system, and they just need to have somebody come in and go, all right, we've gone to the best of our limits just because of what we know of the system. Can you bring somebody in that's got more knowledge of the platform, more experience with the platform, and help us just tune this to the rest of the way that it needs to be tuned? Maybe the shop's got somebody that's got 5 or 8 years experience with SQL Server, and they've done a really good job tuning the system. Excuse me. But they just need to be able to tune it that extra degree, that extra nth percentage, to get the most they can out of that system. Because we're in IT, do more with less is pretty much what we've been working on for the last 20 years now. So we still need to be able to figure out how to actually do more with less. And we need to be able to just do more and more and more. And so one of the ways we can do that is by tuning things as much as possible to get as much workload out of them. Another problem they have is if they've got a lot of tuning, we're literally doing this for a client right now, there's so much tuning that needs to happen that the people on staff just simply can't keep up with the amount of stuff that needs to be tuned. So we've got one system right now in Azure. It's a distributed system, so it's a single tenant system. Every tenant's got their own database. And so they've got about 30 databases right now. And there's just so much to tune because the developers did a really good job building the app, but they weren't database experts. And so they need help tuning the system and figuring out what to tune. And then they can go back and actually, implement those changes. And some of the things we've given them are some best practices so they can then roll forward on those and move those best practices into their normal coding standards. Now, one of the things you do when you get a consultant is you want to make sure you're getting something back from the consultant, not just the tuned queries, but actual knowledge on not just what tuning was done, but why it was actually being done. So you don't want the consultant to just be firing stuff off in the ether and going, yeah, this will work, and going away. You want to know why it's actually being fixed so that you can take those practices that the consultant is showing you and actually use them in your shop in other places. And a lot of that's going to involve training of some sort. So you're going to need some sort of training, either informal training, where you're just kind of doing a side-by-side with the consultant, or in the modern times, screen sharing. Or it could be a more formal classroom style day or two of actual working with the consultant as a trainer and going through what they found in your systems and how to actually fix those things going forward. And that's going to go into training so that you can avoid some of these problems in the future. You want to get best practices back from the code that they're giving you so that you've got something to go forward with without the consultant. One of the things that I know we pride ourselves on is some of our clients have never had to come back to us because we like to teach them how to do stuff going forward so that they can take care of a lot of this stuff themselves without having to rely on us. You don't want to rely on your consultant because that's going to just cost you money. And if it's something you can do yourself, then why shouldn't you be doing it yourself? Any anti-patterns that the consultant sees in your code, and we see them all the time, unfortunately, you'll want to take that information back so you don't do those sorts of things again in the future. And again, this goes back to that first one, is not just what you want to avoid, you want to know why you want to avoid those sorts of things. I've put some reading material together because obviously Tom and I could not cover everything in an hour. And so that information is going to be available at dcac.com/res/SQL-server-performance-string. Sorry, I should have made that URL shorter. I just didn't think of it when I put this together. So I'll flip back to the slide in a second. So if there's any questions, please feel free to put them in the Q&A. Again, it'll take a minute or so for us to respond and see them. I'm going to put that URL back up there. So what I've got up on that URL is we've got some great tuning tips. We've got some blog posts on how to make SQL Server faster that various folks at DCAC have written. So feel free to check those out, and you'll find some great information there on how to make SQL Server faster in general. So I am not seeing any questions coming in, so I'm assuming there aren't any. If there are, please feel free to email myself, denny@dcac.com, or Tom. How can people get in touch with you?
How about SQLrockstar@thomaslarock.com?
There you go. So you can email either one of those email addresses. You can also email DCAC at info@dcac.com. There's our website. There's our Twitter handle. There's our LinkedIn account. Feel free to hit us up on any of those methods. I'm not seeing any new questions pop up, so I'm just going to say thank you all very much for coming. If you haven't filled out your census, today I believe is the last day to fill out the U.S. Census if you're in the U.S. We do have an election coming up, obviously, in the U.S., so please do vote before November 3rd, because that's election day. So if you've got early voting in your state, take advantage of it so you can avoid the lines. This will be our last webinar that DCAC does for 2020, because we're going to give you November and December off. Just because of the holidays and all the other stuff that's going on. So thank you all very much for coming. Tom, thank you for being here with me, and we'll see you all later.
Thanks, Denny. Appreciate it.